What's up, math scholars and math haters? This is Mr. W. We're tackling question 21 of the third grade math questions that North Carolina released this past school year. As you can see, we're now in the calculator active section, so I'm going to be able to use a calculator for the trickier addition and subtraction, multiplication, and division problems. But for right now, we're actually not going to need it for this question, because all we're looking at is we have a circle and some fraction of it is shaded. We're asking which circle has an equal fraction that's also shaded. So in order to do really well in a question like this, you need to know the basics of fractions and also what it means for two fractions to be equivalent. We've tackled questions like this before. You're welcome to look in the fractions playlist that this will be filed under for those other questions. But to start with, let's talk about what equivalent means. I've tackled this in other questions as well. But equivalent means that we're using different numbers to talk about the same idea. So if I have 1 plus 5 and I have 2 plus 4, both of these equal 6. And so we actually have three equivalent expressions here. 1 plus 5, 2 plus 4, and 6 all give us the same number, just we use different numbers to talk about it. So with that in mind, we're going to go ahead and just write out the fraction form of each of our answer choices. So to start with, I just need to make sure that I'm doing the same thing every time. So my shaded pieces will be my numerator, and then my total pieces is going to be my denominator. So if I'm going to do that for my original circle that I'm going to compare everything else to, I've got 2 shaded pieces and then 1, 2, 3, 4, 5, 6 total pieces. So here I have 1 shaded piece. I'll use a different color for these. 1 shaded piece out of 3 total. For choice B, I have 2 shaded pieces out of 1, 2, 3, 4, 5, 6, 7, 8 total. For choice C, I've got 1 shaded piece out of 1, 2, 3, 4 total. And for choice D, 2 of my pieces are shaded out of a total of 3. So now is when I'm going to need to compare some of my fractions. Just by looking at this, I can already tell that it's not going to be D, because way too much of D is filled in to match up to this. So that's a good trick I can use, just looking and seeing what definitely doesn't work. I don't want to eliminate stuff that maybe doesn't work. But for right now, let's just go ahead and take 2, 6 and see if we can get it to match up to one of these. Now for equivalent fractions, all we're going to need to do is multiply our numerator and denominator by the same thing. So let's say that I took 1/4. And I said, okay, I'm going to multiply my numerator by 2 and my denominator by 2. This gives me the equivalent fraction of 1 times 2 is 2 over, and 4 times 2 is 8. So 1/4 and 2/8 are equivalent. Oh, wait. That's what we got here. So that's a good example of how to find an equivalent fraction, but it also tells us that we have 2 answer choices that are equivalent to each other. Since we can only have one answer, I'm going to guess that it's not going to be either of those and that it's going to be A. So let's test out choice A. The fraction in this circle is 1/3. The fraction up here is 2/6. I'm going to go ahead and try to do the same thing. Times 2 in the numerator, times 2 in the denominator, which gives me 1 times 2 is 2, 3 times 2 is 6, 2/6. Oh, good. That matches 2/6 exactly. So our answer is choice A. And you could have looked at the pictures and looked at them a little more closely. That's how we knocked out choice D, and you could do the same thing to try to knock out choices C and B, or to say that it's choice A. But personally, I just prefer to go through it the mathematical way so that we know the math.